somewhere in the crowd, but I think that he will appear. Yes, he is making his grand entrance. I have had the great honor of knowing Professor Diczfalusy and Pino Benegiano for almost 30 years. I met them in the context of working on a steering committee of the World Health Organization, and I've had the good fortune of remaining in contact with them for all these many years. So I think I'll try to briefly recollect Pino's history, and then he can come up and give us a good version of Egon's history. As I said, Pino was managing a task force on long-acting methods of fertility regulation at WHO when I met him. He then went back to Italy. He came back to WHO to head the special program on research in human reproduction, and then went back once more to Italy, where he took on a leading position within the Italian government, and I can't quite describe the title, but it was responsible for essentially the NIH, the FDA, et cetera. He has been a mentor to me, although he's not that much older, but he certainly introduced me to many of the aspects of contraceptive research, and particularly to the international aspects. I had been working at the National Institutes of Health, which is in the U.S. somewhat provincial. In any case, I'm very happy to be able to introduce Giuseppe Benegiano. Please.
Dear Egon, dear friends, to try and retrace all the achievements in the long life of Egon Diczfalusy is at the same time fairly easy because I've known him for 43 or 44 years, so I followed almost every step of his life. But it's very difficult because it is certainly not something that can be done easily to show all of the many, many facets of his personality. And although you cannot read what it says up there on the dedication, it says to Pino, so this is a photograph that I have in my own office from him from the early days. Now let's see if I know how to. This one, huh? Okay, so I have decided that Egon's life could be divided into 5 epochs. First, growing in his native Hungary, then the days at the Hormone Laboratoriate, then founding with Alex Kessler the WHO expanded program of research in human reproduction, and being a consultant for 25 years. Then working for an aging humanity, and last but not least, what I have called from the famous movie, Return to the Future, Return to Szeged. So Egon's first life is in a country that is quite familiar to most of you, and as you probably know, he grew up between the 2 World Wars, and he gave me, years ago, a number of pictures from his family, and the family comes from a family of military people, and you can see his father and mother. And then this is another picture from the beginning of the century. I'm not sure whether these are the grandparents. And yet one more military member of the family. This is something that I like because it's Egon's family. It's the grandfather, the father, and an uncle, all dressed in the military uniform. And now, this is where he was born. I don't know if I can pronounce it properly, but it's something like Miskolc. And the next shows apparently the street where his house was when he was born in pre-war or in between the two wars in Miskolc. And the story about Egon's second life, the one in Sweden, started when he, as a second-year medical student, was working with Professor George Ivanovich, and he was working on enzymes of bacteria. And the famous Professor Hans von Euler, the Nobel laureate in Sweden, had done a certain study, and Egon, as a young student, repeated it and couldn't get the same results. So his professor said, we need to publish it, because nonetheless, he's a big guy, you are a small guy, but if these are the data, these are the data. And Egon subsequently wrote that this was probably instrumental in the beginning of his second life, is moving to Sweden. And here is the professor that started Egon's second life. And when, years later, he gave the Sir Henry Dale Lecture for 1978, which he named Reproductive Endocrinology and the Merry Post-War Period, he recounted how he became a reproductive endocrinologist. And here it is, from his own words. How did I become a reproductive endocrinologist? By the Hungarian approach. As a second-year medical student at the University of Szeged, I was working in the Department of Pathology and Bacteriology of Professor George Ivanovich. And my first task was to repeat a study by the Nobel laureate Hans von Euler and his co-workers in Stockholm, who found transaminase activity in suspensions of yeast and Escherichia coli. It's always Egon speaking, I just could not confirm their findings, and my professor felt that I must publish this. This negative report, Diczfalusy 1942, was my first publication. It was probably instrumental in bringing me to Stockholm after the war, when I had the privilege of working as Professor Hans von Euler's assistant during the years 1946 and 1947. I don't know, because we never discussed it, what was the spirit, what were the emotions when Egon left home, when he left Hungary in a country in trouble and moved to an entirely different. What I know is that in the early days at Karolinska, he told us some stories from Hungary at the time of independence. And I will just tell you two of those very briefly. One was about an officer who became a regular guest at Egon's family luncheons for 1 month. And so he asked his father, I know he's a good friend, but why is he coming every day for lunch? And he said, well, he met a beautiful young lady and wanted to celebrate. So he went into a cafe, he invited every single person in there, closed the doors, and finished his monthly salary. So he needed to be fed at lunch in Egon's family's home, and at dinner, I suppose, someplace else. The other story of this, what I will call vie de bohème, was another officer who again fell in love for a girl, and she said that she would love roses. So the guy got on the Orient Express, went to Istanbul, bought the roses, and came back and gave them to this newly found love. Now, Sweden was different. And so the second part of his life had to be different. This is the paper I just mentioned a few minutes ago from Egon, and he knows that I don't know German, and so I cannot translate. But this is when the two, the old Diczfalusy, the young Diczfalusy and the old von Euler, came together to sort, I suppose, of agree on whatever happened in the Escherichia coli. Then came the move, which I guess was the move of his life, the move to the Kvinnokliniken, the women's disease department. And here is the chairman of the time, who I remember this picture in Egon's lab, and I can only tell you that it brings memories to me, Professor Axel Westman. And in 1953, he then completed his thesis on chorionic gonadotrophin and estrogens in the human placenta. And that thesis really moved his life for probably 20 years. And he was working happily in his lab when in 1963 everything changed. This is in Swedish. I know Swedish a little bit more, but not enough to translate for you. But it says that Docent Diczfalusy was awarded one of the biggest Ford Foundation grants ever in reproductive endocrinology, $500,000 of 1963, to work on fetal endocrinology. One of the good things, and I alluded to that yesterday talking about Professor Mancuso, was that that grant allowed for a number of young researchers to come to the lab, beginning what ended up with 150 graduate students working in his lab. And this is a picture from the early days. I remember the first to the left, Austrian called Zimonich, and I don't remember exactly what kind of a mess he made in his lab, and Egon wrote over this pile of junk in German, and I only remember two words in English because I don't remember the German, but it meant humans don't behave like, regular humans don't behave like that, Kannibalen behave like that. So you see the second is Professor Mancuso in his early days, and then come all of the others. I am the fourth. We started a life together at that time. And then in 1965, we went to the 5th Acta Endocrinologica Congress in Hamburg, and yesterday I alluded to that. This was the first important meeting when we were allowed to give presentations. And this is, in my view, one of the original papers because of everything that followed in terms of the fetoplacental unit, because it talks about the mechanism of formation of estrogenic hormones. And that was then the scope of our research for years and years. And the publications of Egon exceed by far 500, 600. And this one shown here, is a sort of a scientific autobiography, the contraceptive revolution, an era of scientific and social development. Egon and my friend Paul Valnook alluded to that yesterday, became involved from the very beginning with the WHO Human Reproduction Unit, and I will talk about that in a minute. But one of the big accomplishments during his tenure as the director of the WHO Research and Training Center in Stockholm was setting up a series of symposia called Karolinska Symposia on Research Methods in Reproductive Endocrinology. And for a number of years, that was like a Bible for anyone who wanted to start working in reproductive endocrinology. Another paper, and the only reason you see it is because the third name is mine, and it was the first paper that I published with him. There were tons of them. And this is also another paper that I quote because my name is next to it. And again, I cannot show you the papers. What I can tell you is that the group expanded, the group became more and more international, and here is another picture from the days of Karolinska. But we didn't only work, we also had fun, and this is a picture taken by Professor Mancuso of a bunch of youngsters, because Egon was young, Anne was young, I was even younger, and the two children were young, very young, in an island off the coast of Sicily called Ustica, where we had great time. But, you know, everything ends up on the face of this earth, and so even my stay ended. And Egon was sort of jealous of all of his students who, by the very nature of being graduate students, had to go back, had to move into the world. And when I left, he called me up and he said, are you going to the Population Council because you will get a better salary, or because you like better the type of research they do there, or because you will be able to do better politicking there? And I don't know what inspired me, but I looked at him in the eyes and said, but of course, all the three, sir. Then came Switzerland, then came WHO, then came Geneva at the very end of the Swiss map. when in 1972, he was more than instrumental. He was the engine behind pushing Alex Kessler, at that time the chief of the Human Reproduction Unit, a small unit in the big WHO, to create what in those days was called the Expanded Program of Research in Human Reproduction. And the two of them received initial grants from the Ford Foundation, from the Swedish government, from other Nordic governments, and this program was started. And there again, they had money to create new positions and expand the work. And he wrote to me and he said, would you like to come? And I said yes, and so I submitted my papers, and he said, look, there is someone else that the Ford Foundation wants to loan to us, and if he accepts, Gordon Perkin was the person, then this is for free, and so it will be preferred to you. So I had to wait one more year until further expansion, and the program was willing to spend its own money, and I got on board. And Egon was on just about every task force of the program. Here is the long-acting that Henry Gabelnick alluded to. And he, I don't know if he started, but certainly he expanded his traveling to the 4 or 5 corners of the world, and probably is the person who traveled most of all the people I know. I traveled with him, and he should have traveled with my wife, because I tell people that whenever she flies, she goes in at 5 o'clock and opens the airport to make sure that she is on time. And Egon was a bit, and he is a bit like that. I remember once we were at a meeting in Alza Corporation in Stanford, and in Palo Alto. And he said, we have to go. And I said, look, it's 3 hours, so it's only 40 kilometers. There is a freeway. He said, yeah, but the freeway is full of traffic. I said, no, we will take the other freeway, the Junipero Sierra. Don't worry. Eventually, I had to give up, and we stopped the meeting, went. We arrived, I don't know, 40 minutes before departure, and in those days, there were no securities, no second, third check. So I said, Egon, are you happy? This is 40 minutes before. And he looked at me and he said, but the gate opens 50 minutes before. So we were 10 minutes late. Here is another picture in Thailand, I believe, with Professor Goldziher is the last on this side, and Egon is, of course, right in the middle. And when he sort of reflected upon those years, he said the modern interpretation of history is said to be based on the analysis of the history of ideas. The history of the second part of the 20th century represents an entirely new departure in this respect. For the first time in the history of mankind, the policies emerging from world conferences organized by the various specialized agencies of the United Nations broadened the views and perceptions. And among the many meetings, the many events, several took place in this very city. And you see Egon here with Laszlo Kovacs, at that time the chairman of the department. And it was here that, like a swan song, I said goodbye to the program, to the WHO program, with a symposium to celebrate the 25 years of the program. Symposium edited by Laszlo Kovacs and Bela Resch. And in this meeting, he said, I myself represent the future. Yes, you heard right, I said the future. I represent the future of the past. As Paul Valéry puts it, are you not the future of all memories stored within you, the future of the past? And here is one of the pictures taken by the group in Szeged again, and if you look carefully, you will recognize a number of people. There are too many there to be, but I see even my mother there. And there was a surprise for me, because I turned 60 in basically during that meeting, and so Laszlo organized for a surprise party, and this is a picture from that surprise party at the place, what do you call it, Spheristerium, where the epic of Hungarians reaching this region from Western Asia is pictured. So another reason why I am attached to Szeged. And this is the two of us during that symposium. And I wanted to show this one because it shows Egon, Anne, and myself. But life doesn't stop, and flying continues, and engagements continue. So I called this fourth life of Egon the world, not because he wasn't a worldly figure, not because he wasn't interested in the world, but because at that point he became truly a citizen of the world almost without a base. And as he was aging, as we all were aging, he turned his attention to the aging humanity. We have an epidemic of us today, and something needs to be done to improve the quality. We can live 90 and 100, but the quality usually is not the best. So there is a need. And I was asked to write for the Women's World Report of FIGO in 1997, an article about women in the third and fourth age. I was buried in work because I was in between being the director of the program and moving to Rome to become the director of the Italian National Institute of Health. So I said, Egon, will you help? And he did. He wrote the whole damn thing, and I just put my name with a few minor changes just for the sake of it. And here is another quote. I obviously wish to give you just a few because of time, but he said, the wind of new realities is blowing with increasing strength. It is up to us to decide whether we prefer protective windscreens or new types of windmills. I bet you all know that Egon does not cherish protective windscreen. And this is one of the latest lectures he gave, The Demographic Revolution and Our Common Future. Too many grandparents for too few grandchildren. Where are we going? He gave that last June in Rome. And this is the last, the official story and the true story by Egon Diczfalusy. He got all kinds of awards, and yesterday the Royal Thai ambassador mentioned the Mahidol Award. Prince Mahidol was the father of the King of Thailand, Bhumipol. And I remember that I wondered, well, but if he was the father of the king, how could he not be king? And in fact, he wasn't king because the king was assassinated, and the younger brother was already dead. So they passed on the crown to the son of the younger brother. And that's why the Prince Mahidol and not the King Mahidol Award. And this is the royal princess giving him the award. Another award was the degree honoris causa in sciences at the University of Edinburgh. And I could go on for half an hour, but I stop here to finish with Egon Fifth Life. And I called it, paraphrasing Steven Spielberg, ED Phone Home. And here we are, back home, back to the future, with yet another episode in his long life and career. And I guess you are all familiar with this picture, because Szeged comes back and back and back in his life. Perhaps when he left, he thought that was it. And I remember when he started coming back to Hungary that he said, you have no idea how difficult it is for me to speak in Hungarian. You bet it's no longer difficult. So things have changed. And here is the end of the story. As of today, the establishment of the Egon and Anne Diczfalusy Foundation for the support of scientific work conducted in the field of reproductive health. Thank you very much.
Thank you very much for that wonderful summary of an amazing, amazing life. And I hope I'll come back here again to hear about the fifth life, and we're looking forward to that. Now I'll turn the microphone over to my colleague, Laszlo Kovács, to introduce the next speaker.
Thank you. Ladies and gentlemen, I have the pleasure to announce the next speaker, who is Professor Kristina Gemzell-Danielson, and that is not her first visit to Szeged, but she has been here several times, and that reminds me also to the strong and active and fruitful collaboration between the Stockholm WHO Center, and that was led by Mark Bigdeman, and also ours here in Szeged, where I was a director, and that was also Christina who was working with us. And now I would like to announce her presentation, that is the mechanism of action of emergency contraception, and that is really very interesting for us, because emergency contraceptives were several times accused that being abortifacients, and I really look forward for your presentation. You will explain us how it is. Thank you.
Thank you very much, Egon and my friends in Szeged, the organizers, and all colleagues and friends. I'm very happy to give this presentation. So I'd like to, emergency contraception has been called one of the best kept secrets in family planning. And I think today it's probably not a secret anymore. But what remains a secret, and also a matter of discussions and debates and political fights, is the mechanism of action of hormonal emergency contraception. So that's what I will focus on. The definition is important. It's any method used after an unprotected intercourse to prevent an unwanted pregnancy. Thus, it's defined as a contraceptive method and not as a method of abortion. It's probably the oldest method for contraception, and this is the description in the first textbook of obstetrics and gynecology written by Cyranous of Ephesus around 100 years after Christ. And he said that a woman ought, in the moment during coitus when the man ejaculates his sperm, to hold her breath, draw her body back a little so that the semen cannot penetrate into the os uteri, then immediately get up and sit down with bent knees, and in this position provoke sneezes. She should then wipe out the vagina carefully or drink cold water in addition. He didn't report anything about efficacy or acceptability. And fortunately today we have some more options. So it's the classical Jusper regimen described by Dr. Jusper in the 70s and consisting of combined oral contraceptive pills taken in repeated doses with a 12-hour interval and within 72 hours of an unprotected intercourse. And more recently, levonorgestrel alone or mifepristone has emerged as the most effective hormonal methods with lower side effects and higher efficacy than the Jusper regimen. Actually, the most effective method is the Kappa IUD. It's safe and it's effective, but invasive, and it has some obvious disadvantages compared to the hormonal methods. Following a small pilot study in Hong Kong, the WHO Special Program undertook a large multi-center trial that was carried out in 21 centers in 14 countries, coordinated by Helena von Herzen. It was a double-blind, randomized controlled trial, and in this trial, levonorgestrel 0.72 milligrams twice with a 12-hour interval was compared to the traditional Jusper regimen given within 72 hours of the unprotected intercourse. And the participating countries were selected sort of all over the world because this was also to increase the knowledge on emergency contraception. And the results were surprising. The study showed that levonorgestrel is more effective than the Jusper regimen, that it was better tolerated, lower rate of side effects, and that for both regimens, earlier treatment was more effective. And in the next large multi-center trial that was also published in Lancet in 2002, the levonorgestrel regimen of 0.75 milligrams twice was compared to giving a single dose of 1.5 milligram. And in this trial, mifepristone in a low dose, 10 milligram, was also included. And it was 4,000 women in 10 countries and 14 centers participating this time. And the results showed that all alternatives were equally effective. And in this trial, it was also shown that although the efficacy was higher the sooner the treatment was given, there was an effect up to 120 hours. So, following these trials, levonorgestrel 1.5 milligrams as a single dose became the standard for emergency contraception. And there are no contraindications. I mean, ongoing pregnancy is listed as a contraindication, but it's important that it's not because it would damage the pregnancy, it's only because then it's too late to have an effect. Repeated treatment can be given during the same cycle if needed, but may increase the risk for disrupted bleeding pattern. And it should also be remembered that emergency contraception is less effective than regular contraceptives. Today, levonorgestrel emergency contraception is available over the counter in many countries. But concerns about mechanism of action restrict the use in many areas, and as I said, is a matter of debate. So, and it's also, it is also frequently mixed with medical abortion. And thus it's even illegal in some countries in the world. An unprotected intercourse can result in a pregnancy during a short period of the menstrual cycle, that is about 5 days before ovulation and including the day of ovulation. So to be effective, emergency contraception has to target one or several of the events that I've listed here. And I will address them each with regard to the effect of levonorgestrel in relevant doses. So if we start with the effects on the human sperms, sperms can be retrieved from the endocervix within 90 seconds of insemination and in the fallopian tube in 5 minutes. So if that was the main mechanism of action, it would have to be used really very fast. Progesterone triggers the acrosome reaction of capacitated human spermatozoa in vitro. But when the effect of levonorgestrel was studied in vitro, there was no direct effect of doses relevant for emergency contraception. In the classical studies by Casero from the 70s, levonorgestrel was taken 3 to 10 hours post-coital, and a number of effects were observed, such as reduced number of sperms in the uterine cavity, immobilization of sperms, increased viscosity of cervical mucus, and changed composition of the uterine fluid occurring 3 to 10 hours following treatment. Taken together, it seems like the effect of levonorgestrel is not, there is no direct effect on the sperms, but rather an indirect effect by the effect on cervical mucus and uterine fluid. So this effect is unlikely to be of any significance when the method is used as a post-coital method, although it's of course very important when it's used for regular contraceptives. So then if we look at the effect on follicular development and ovulation, to study this, we recruited healthy women with proven fertility. They received total dose of 1.5 milligrams of levonorgestrel either pre or post-ovulatory, and they were followed for control and treatment cycles. We obtained endometrial biopsies on cycle LH plus 6 to 8 or corresponding days in case of anovulation. And we also followed hormonal levels. So following pre-ovulatory treatment, and that is treatment on approximately day LH minus 2, the LH surge was inhibited in all subjects. And here, now I don't have a pointer, but you can see no LH surge following pre-ovulatory treatment compared to the normal LH peaks following post-ovulatory treatment or in control subjects. We also studied the effect on follicular growth measured using ultrasound. And treatment was given at a diameter of more than 50 millimeters, at a mean of 18.1 millimeters to 7 subjects. And the follicular development was either arrested or treatment resulted in unruptured follicles. In a similar study conducted in Edinburgh, levonorgestrel 0.75 milligrams twice was given also to healthy volunteers, and treatment was given on or before the LH rise in urine. And various effects were observed depending on when treatment was given. So treatment either resulted in anovulation or delayed LH peak, or if treatment was given when LH had already started to rise, there was no effect on ovulation. And there was also reduced cycle length. And these results is very similar to what has been observed in animal studies, that closer to ovulation, the effect declines. So taken together, levonorgestrel interrupts development of the dominant follicle if given before the onset of the LH peak. If given when LH has already started to rise, ovulation is not inhibited. There is no effect. There is also variable effects on follicular growth, delayed development, inhibited growth, or unruptured follicles. And as I said, closer to ovulation, the effect declines. So then we come to fertilization and implantation. And this slide shows that under the influence of progesterone, there is a dialogue or exchange of signals between the developing embryo and the maternal tract, the fallopian tube, and the endometrium to ensure synchronization between the blastocyst and the receptive endometrium and to allow implantation to occur. When we studied the effect on various, some of these factors you saw on the last slide, in the fallopian tube, levonorgestrel had no effect. And the same was true for expression of progesterone receptor. There was no difference in controls or following treatment with levonorgestrel. And the treatment here was given on LH plus 2, and fallopian tube biopsies obtained approximately on day LH plus 4 to 6. So then if we move on to the effects on the endometrium, treatment was given in the same way on LH plus 2, and here endometrial biopsies were obtained on LH plus 6 to 8. There are a number of suggested markers of endometrial receptivity, and you see some of them in this slide. I won't get into the details here, but and yes, this slide shows the receptive endometrium at the time of expected receptivity, and it shows expression of pinopodes, which are beautiful, I think, large formation from or protrusions from the luminal epithelium. So when we studied the effect of levonorgestrel given post-ovulatory on the endometrium, the cycle length remained unchanged. Hormonal levels remained unchanged. We saw no effect on endometrial histology or morphometric analysis that Elisabeth Johannesson also helped to perform. And we saw no significant effect on markers of endometrial receptivity. There was no effect on urinary levels of glucuronide hormones, estrogen and pregnenolone glucuronides. So, is there any direct effect of levonorgestrel on the embryo? Well, in animal studies, there is no direct effect of relevant doses. There is also an ongoing study in Shanghai, in China, conducted by Lin and Cheng and co-workers, where women exposed to levonorgestrel, but with a subsequent, or with a becoming pregnant in the same cycle, and who chose to continue the pregnancy. They are followed during pregnancy, and newborn babies also followed in the neonatal period. So far, about 200 women has been recruited and followed, and there is no effect on the pregnancy or on the newborn baby. What remains difficult is, of course, to study the effect on the implantation in humans. And that is one of the largest matters of debate. What happens? Is there an effect on implantation? So to be able to look at this, we developed an in vitro model for human embryo implantation studies. And the aim was to understand the process of human embryo implantation, to understand progesterone-regulated endometrial receptivity, to be able to study this dialogue or exchange of signals between the embryo and the endometrium, and also to study potential measures for fertility regulation. So the design was that we constructed a 3-dimensional endometrial cell culture system. And we have also shown that the immunohistochemical analysis of suggested markers of receptivity behave as in the in vivo studies. After that, we established the in vitro human blastocyst implantation system. And then we studied the effect of levonorgestrel and also of mifepristone as sort of extra control. And of course, we had ethics permission for this. Endometrial biopsies were obtained, as before, from fertile human volunteers, and embryos were donated from couples undergoing IVF. The endometrial biopsies here were collected a little bit earlier, on LH+4 of the menstrual cycle, and part was kept for endometrial dating and histological examination. The endometrial biopsies then underwent mechanical and enzymatic isolation to separate the endometrial cells. And this is briefly how it's done. First, the cells are separated into stromal and epithelial cells. Then the stromal cells are embedded into collagen matrigel. And after that, epithelial cells are seated on top of the stromal cells. And in this way, we receive an endometrium that actually quite well mimics the endometrial obtained in vivo. And it even expresses pinnipod-like structures, as this slide shows. And this is how it looks. This is a section where you can see stromal cells, and on top the epithelial cells that has formed a sort of luminal epithelium. And this epithelium also expresses various steroid receptors ER alpha, beta, androgen receptors, and progesterone receptors. It expresses various cell adhesion molecules. This is integrin alpha V beta 3, which is one of the suggested markers of receptivity. Mucin is another one. And interleukin 1 beta, and also LIF that has been shown to be necessary for implantation, at least in mice. And it's LIF produced by the endometrium. And VEGF is also expressed in this construct. So the next step was then to add the blastocyst to this 3D endometrium. And when the blastocyst is added, then we allowed the culture for another 5 days with progesterone, that is the control, mifepristone, or levonorgestrel. And then the whole insert is removed and the endometrium is sectioned. So this shows the effect of levonorgestrel on blastocyst implantation in vitro to the right, and compared to the control treated with only progesterone to the left. And there was no difference in implantation rates. This paper is now in press in Human Reproduction. We also studied the effect of mifepristone, and you know that mifepristone has been shown to affect endometrial development and suggested markers of receptivity. And the contraceptive effect of mifepristone seems primarily to be due to an effect on endometrial receptivity. And these effects on the endometrium also seems to be dose dependent. So 10 milligrams has only minor effects on the endometrium, while 200 milligrams totally blocks the development. And following treatment with mifepristone, no implantations are seen. And now I just have some beautiful slides. Maybe it's not dark enough. This is one of the implanted, it's not implanted, it's the early stages of implantation. So this is the attachment of a blastocyst. And when it's at an early stage, when the attachment is not firm, we can make it fall off. And this is how the epithelial layer looks underneath the hatched blastocyst, with a destruction of the lining epithelium. And this is another picture of an embryo attached to the culture. And another one. And this one starts to invade, and you can see how the whole epithelial surface, I don't know how to call it, but it started to sink in. And another one with protrusions. And this one, I don't know what this one is doing. It looks a little bit strange. And here, so you can see I'm very fascinated by looking at these implantation in the microscope. They're also so beautiful to look at. And this is a cross-section of the implantation site. And when you look at it like this, you may ask, how do you know that this is really a viable embryo? But of course we checked for that. So this is marker for trophoblast cells. And this is another photo that was taken by the famous Swedish photographer Lennart Nilsson of the blastocyst attached to the artificial epithelium. So, taken together, the recommendations for emergency contraception with levonorgestrel is seeing a dose of 1.5 milligrams, and it should be offered during the entire menstrual cycle. And treatment should be started as soon as possible after intercourse, because high efficacy the earlier emergency contraceptive pills are taken, but up to 120 hours. And there are no contraindications for levonorgestrel emergency contraceptive pills, except ongoing pregnancy, because then it's unnecessary. Emergency contraceptive pills do neither prevent nor promote sexually transmitted diseases. I didn't address that now, but that's been shown in studies, and does not increase the risk of ectopic pregnancies. Regular contraceptives can be started immediately. And of course, it should be remembered that the kappa IUD is the most effective emergency contraceptive, but less practical. When it comes to the mechanism of action of levonorgestrel emergency contraceptives, the contraceptive effect is mainly due to impaired ovarian function. But if the effect is mainly to block the LH surge or to interfere with other processes involved in ovulation or both, it's not clear, and that needs to be further studied. I think it can be concluded that levonorgestrel in the doses used for emergency contraception has no effect on the endometrium or implantation. And that levonorgestrel used for emergency contraception is not an abortion method, and it does not adversely affect an ongoing pregnancy. And the molecular profile of the in vitro endometrial cell culture mimics the in vivo situation and allows studies at least on the earlier stages of implantation, that is attachment. I'd like to acknowledge my research group at the WHO Collaborating Center at Karolinska Institutet in Stockholm. And for the cell culture, we collaborated with Dr. Bentin Ley in Copenhagen. The work was supported by WHO and also by the Swedish Research Council. And this is a birthday card to Egon. Happy birthday. Thank you.
Thank you, Christina, very much for your very interesting presentation and also for the convincing statements that emergency contraceptives, levonorgestrel at least, is not an abortive agent in this activity. Now we have some time for discussion, so I am inviting questions or comments from the audience, please. Yes, Pino, please.
Christina, I think that the data you have presented are quite convincing. At the same time, I know they are not convincing enough from an ethical point of view to those who believe that pregnancy starts with fertilization and not with nidation. I believe that to this day we have all failed to say, but an abortion interrupts an established pregnancy 100% of the times, even the very early one. Whereas emergency contraception may interrupt the process after fertilization in a percentage that we cannot determine, but probably less than 50% of all cases. And shouldn't this be considered from the ethical point of view of those who believe that pregnancy begins with fertilization as a lesser evil? It is better to have 50% or 40% chances of interrupting a gestation than 100%. I know this thinking has not gone anywhere, but shouldn't we try to go on this? Because it's not only the strict Catholic teaching. There are many women who feel very uneasy about interrupting an early gestation, and if we could reassure them, it may improve acceptability of the method.
Yeah, I mean, it's really a difficult topic because some people are set and they have their opinion. What I find a little bit absurd is actually that if we had more effect on the endometrium, the efficacy of the method would increase. And that's what we see because what we see, it's been a little bit unclear with mifepristone, but what we see now is that there is a dose-dependent effect. So 10 milligrams have only minor effects on the endometrium. 25 milligrams has a little bit more effect and has a higher efficacy. So I think from the example with mifepristone, we can really see that the more effect there is also on the endometrium as a backup, so it's not only on the ovulation but also on the endometrium, the higher the efficacy becomes. So in a way it's a little bit absurd that levonorgestrel is not the most effective because it doesn't have enough effect on the endometrium.
Thank you very much indeed for that lecture. It is the kind of information we need in our work on IVF, because obviously this is the most delicate part of our work in a sense, and we need to know every little bit we can get to know about these stages. So your work is very appealing to me. I want to raise with you some aspects of human conception that have always interested me. One is very simple. In animals, you must replace an embryo on a certain day. And it's usually about day 5, day 3, when the blastocyst is formed. In human, it is impossible to put into the uterine cavity an embryo or an egg which is not fertilized, but has sperm attached to the zona pellucida. And fertilization takes place in the uterus, and implantation takes place in the uterus, and the pregnancy rate is almost as high as with natural conception. So you must accept in some way that the endometrium has a constant expression of secretions from the moment of ovulation, and maybe even before, which surprises me. So where does this fit in with all your work? How do you see these great differences, which make studies on things like rhesus monkeys totally irrelevant to humans, by the way, and explain to an innocent scientist like me how the uterus can be so stable despite these fantastic hormonal changes in the luteal phase? That's my first question, if I may.
Well, that's my own question, I would say. I mean, I'm intrigued by the endometrium, and of course it's not easy to study it, as I said, in vivo, and it's not so easy to study it in vitro also. These studies I've been doing for 10 years. I went to Cambridge to learn to separate endometrial cells, and then we have been working on it. But I mean, it's difficult because it's only during certain. We have to obtain the biopsies during certain days, so it has to be LH+4, 5. If we take them earlier or later, it doesn't work. So it is somehow it's very controlled. And I'm fascinated also by this exchange of signals between the fallopian tube, the embryo, and the endometrium and the embryo. And that's, of course, what we hope to be able to study a little bit more in this model.
It's interesting to me that the fallopian tube seems almost unnecessary for human conception. It's merely a transport system. I think we're agreeing on that point. And the contraception would take place in the uterus. There's another thing I would like to raise. Work now on, I would say, hundreds of thousands of human embryos have shown that the problem with many embryos is that they have abnormal chromosomes. It is a fantastic figure. It is 50% of embryos have chromosome anomalies. This is an amazing question to ask, and in my opinion, it needs a great deal of study. There is recent work on the use of what we call in vitro maturation of oocytes, where we use no hormones at all, and we simply extract the egg from the follicle, fertilize it, and pop it back into the uterus. And in these ways, you can learn all sorts of things that don't seem to fit in. The pregnancy rate appears to be the same, as far as I can see, with IVF. And the simplicity of it is so easy that I would think that the high cost of IVF will be cut by 50, 60, 70%. That's an economic point that we're going into. But do you have any explanation as to why so many human embryos should be chromosome normal when this does not occur in other species? It is unique to humans. Do you think, as I suspect may be the case, that when we give HMG and HCG, which is, I'm now trying to increase fertility, whereas you're trying to decrease it, but I think it is the same systems. There's just a suggestion that the oocyte might be sensitive to steroid hormones. And there's a man in Spain, I've forgotten his name, who says that he believes that the effect of estrogen on the egg is to affect the meiotic spindle, and therefore cause chromosome anomalies. Do you have any information?
No, not yet, and no. I don't know where I will get that, but it is an ongoing study on this that is very interesting. But no, we don't have any results yet.
Yes. Can I ask one last question? One final point that I think you were fitting with beautifully, if I may say, is that in UK we're allowed to culture human embryos to day 14. So far, the latest I know is day 9 or day 10, although maybe Geraldine Hartshorn in Leicester may have a few more because she's studying a great deal of early embryos. And it is fascinating. I'm going to show some pictures later on. It is fascinating to see this day 9 human blastocyst. It no longer has an inner cell mass. It has what we call an embryonic disc. It is packed full of stem cells. It screams stem cells at you. It's an amazing sight to see. You'll see it later, by the way. But again, have you tried going to later stages for interfering with conception?
Not yet, because now we only have ethics permission to culture for 5 days.
Yes.
So, but that would be the next step, hopefully. But I don't know, we haven't applied yet.
Well, I'll come and culture the embryos for you.
That would be nice.